come to us with their design. We have a facility that we can build their semiconductor for them. So they come come to us with a design, we build their chips for them and sell them to them. Traditionally, it used to be where I came from up in Burlington, Vermont, IBM built chips for, built and designed chips for themselves and for other folks. They did all the design and all the building. But now it's getting to a point where folks design their own items and then the fabs are building them. So Pat will go through this.
And as far as the cost of a fab, do you know how much a fab costs to build? No. It's talking about billions of dollars, right? Billions. I don't have the exact number of what an average fab costs, but for 300 millimeter, we're talking about between $5 and $10 billion to build nowadays, right? And for a small startup company that wants to build chips, they can't afford that, right? You don't have back investors to focus on that. So this is where the industry is going. Back, for instance, Intel makes their own chips, they have their own factories, right? Intel makes billions of dollars, they can afford to make their own chips, right? But for the smaller guys, they're looking to reach out to companies like us to build chips for them. Our main competitor is TSMC. If you're here at TSMC, okay, you don't want to work for that. But so basically, we're located in Malta, New York. Our factory is about 400,000 square feet. We're gonna go through these slides pretty quick. So we want to show you the video. I think it'll just give you a better idea of who we are. It's on YouTube, so you can access it at any point. We do have sites all across the world. Our headquarters is in Silicon Valley. And when you build a factory, you need companies to support the factory. And also you need a good location where there are universities as well, because we want to recruit the best talents. The state of New York also helped out because the biggest thing is they said we're not paying taxes for 10 years, so you can build a factory here. They gave us land, and it was an old military site, and we put a factory right on top of it. So we put this 400,000 square foot factory, and we have all these companies who help us run the factory, right? So we have a wide area as far as where we're at, where you can go. I mean, we're centrally located. I used to live over here, right? I moved to Malta about 2.5 years ago. But it's a very good area to live. We're right in the middle of everything. If you like skiing, hiking, boating, whatever, we have it, right? Even camping is very big up there. Horse track racing is very big. So it's an awesome location to live. If I were to, to be honest with you, I like living outside of Boston because I like baseball. I got to see the Red Sox win 3 World Series, right? But living here is, I think, was my best decision. It's a really, really cool place to live. It's very not a lot of people. Only during the summer when we have a track season, but there's so much stuff to do, and everyone's very nice up there. So, I'm not saying people in Boston are not nice. It's just there's just a lot of people. So, go through the next slide. So again, there's tons of things to do. I mean, horse track season is huge. Last year I went to, you know who American Pharoah is? Our last Triple Crown winner. So he raced up there, right? So he won Triple Crown, come here to race and he lost. So we got to see him lose, but it was pretty cool to see the Triple Crown winner. The last Triple Crown winner was back in the 70s with Secretariat. Go ahead. So basically, our campus is right here, built in Nova Forest. Right, so basically it's a very residential area. Back here, Saratoga Lake, if you like boating, swimming, we have everything there. Our fab's complete now. I think you can see right here is we have this factory here, our facilities, which we call the Cub. That's what supports the factory when you have all your electrical and chemical and gases and everything that supports it. This is not built yet, right? But if we were to build another factory, it would go right here. All the factories would interconnect, right? So we utilize every single square inch of the factory, every single factory. Where the clean room is, this is all really it. You're in a room, very big, you have very fast airflow coming through, right? So to keep particles at a minimum. And Air comes through the top. All clean rooms are designed differently, but our specific clean room is designed like this. So air comes through the top, it comes straight down, we have laminar flow. It comes through the bottom of the floor and goes back up. So it constantly circulates through the factory. This is what a clean room looks like. We have equipment there. We'll go through the video. Here's some technicians working on specific applications. We have process. We have guys on the equipment team over here. Go ahead. So as far as manufacturing, how you build a wafer, we have these key modules to make a wafer. Okay? And then it goes back out through a test sort of area where it gets split up into, they dice it, slice it and dice it, and they package it, and it goes to the end user, who would be us. Which is right here, the final product. Yeah, we can go through all this. So here, we have a 3D circuitry right here. You can see how the transistors are built, right? So it's basically a lot of patterns, right? It takes about, I think this slide said 3 months, right? Depending on the product and how fast it's going through the line. But it's a lot of work to build a specific computer chip, and it costs a lot of money. And here, source gate drain, you guys know what that is? It's your first semester, right? So you have your transistor here, and this is where, once you start learning all that, all the basic theory of operation, this is what it looks like. All right, on a very micro scale. Some more products. So we're in everything, gaming, servers, with your desktops. Yeah, we can go through this. So as far as careers, why we're here today is to educate you guys on who we are, right? We have a lot of jobs open. Our factory continues to expand and get bigger. We look for, right now we're hiring entry-level candidates, right? So you're just right out of college, you have no experience, we want to hire you guys. So there are a lot of good programs where we work, Global Foundries, that would be applicable for what you guys learn here, right? So basically, everything you take in class for basic theory and hands-on. Not all the stuff that you learn will be used, but a lot of this. But there's some stuff like key classes that you would basically relate to within the manufacturing environment. Our area, so I'm the senior section manager in the automation department, all right? And Jason works with me in the automation department as well. And we're going to show you a video. I think it will explain it a little bit better. So maybe 15, 20 years ago, say 20 years ago, that in order to build a wafer, you needed a human to pick up a lot, which is 25 wafers, from point A to point B. We have robots doing that now, right? So as we sit here, our factory's running, right, automatically. So everything's automated. It creates a lot more problems though. When you automate something, you have to have more people to manage it, right? There's so many different systems that are running in the background to make it run. So just because we put robots in, everyone's like, oh, put robots in, we're losing jobs because the robots still need to manage it. And you still need engineers and technicians to work on it. Okay?
We don't make self-fixing robots yet.
Yeah, no self-fixing robots yet. Oh, so as far as community volunteering, I mean, there's a lot of cool programs up there. Is anyone familiar with the robotics program that are run in high schools? All right, so a lot of you are. That's great. So this guy right here, Brett Brimhall, he introduced this program to Global Foundries as far as, hey, we need to get involved with the community. So we donate thousands of dollars to local programs up there to make sure this happens. This happens at what's it called? RPI.
Yeah, they did it at RPI in the last 2 years.
The last 2 years?
And then, I think the year previous, the year before, Brett's son and their team actually ended up going out.
National tournament, right?
Yeah, they went out to St. Louis. Yeah.
So basically what this is that Global Foundries wants to invest in, right from school, high school, right, middle school, wherever it is, right? So when you get into college, we look for that. We have jobs open right now, so Brett's helping me send the communication out to kids that he used to work with in a robotics program, right? That when they were back in high school, to see where they're at. They're still in school, they went to college, they're looking for jobs, whatever else. So it's a great network to be in, because you can build a lot of relationships that will last a lifetime. So, yeah, just click on that. Does anyone have any questions right now? All right, so again, we're in the automation department. We have robots that deliver products, right? We also own other specific aspects of the process, but this is one of the main things that we work on. And this will give you a brief video of the factory, what it looks like, how things are made. Do we have audio in here? Okay.
There's a volume control there. Oh, it's a good day.
Let our experts walk you through the nanocosmos of the atom. A world that normally remains hidden from our eyes. In the beginning is the circuit diagram. At design centers around the globe, experts collaborate to design circuit diagrams, sophisticated integrated circuits like microprocessors, high graphic processors, and wireless communications ICs. The next step is manufacturing. The disk substrates for the microchips are made from quartz sand and are called silicon wafers. To make these wafers, a huge monocrystal is drawn from purified silicon melt. The result is a perfect silicon lattice, into which the transistors will later be fitted. However, impurities pose a threat to these flawless silicon crystals. Our GlobalFoundries manufacturing teams must therefore take extensive precautions every time they enter our dust-free clean rooms. The result? Our wafers are fabricated in an environment that is more than 100,000 times cleaner than an operating theater. Completely free of dust, the silicon discs arrive at the clean room. Here, 25 wafers are packed into each hermetically sealed container and sent off on a journey that will take them through hundreds of manufacturing steps.
So there's the automation system right there. That's what we manage and work on.
Photolithographic techniques transfer the circuit structures to the wafers, rather like slide projection. The key to this whole process is a solid mastery of light. The silicon disc is spin-coated with a photosensitive resist. UV light transfers the circuit structures depicted on a mask to the wafer. The exposed parts of the resist are soluble and are removed by a developer. The transferred structures can now be used as a template. The unprotected parts of the water surface are etched away. The structures of billions of small current switches are generated on each wafer, tiny transistors. From the photolithographic stage, wafers move on to the ion implantation, where the electrical properties of the transistors will be specified.
NPN or PNP?
Here, the engineers make good use of one of silicon's most important properties. Silicon is a semiconductor, which means that its conductivity can change via a high precision emplacement of so-called dopant atoms. First, dopant atoms are injected into the silicon structures. These atoms then distribute randomly in the silicon lattice. At high temperatures, the doping atoms become flexible and take on a fixed position in the atomic structure. The complexity of manufacturing tiny transistors requires a clean room as big as 2 soccer pitches. While our people monitor the complex processes, automated manufacturing itself always takes place within hermetically sealed production lines. Copper dominates the next process step. The finest interconnect wires link up billions of separate transistors to form integrated circuits. Before that can happen, however, cleaning is essential for wafers, as particles lurk at every stage in the manufacturing process. Before the copper is poured into the trenches with the interconnects, a barrier layer is applied. It helps to avoid short circuits and guarantees reliability. The trenches are then filled with copper. Finally, the excess copper is ground down to the edges of the trenches. This insulates each interconnect from the others. A microchip made of copper wiring established GlobalFoundries as the first company in the world to adopt copper in volume production. A foundation for the state-of-the-art multi-core processors that GlobalFoundries is introducing today in all product areas. To keep us on the leading edge of the world's chip makers, electron microscopes constantly monitor every step in the manufacturing process, down to the atomic structures of each individual transistor. In 2 months, the wafer is ready. Huge integrated circuits consisting of conductors with a length of multiple kilometers link up 100 billion transistors on numerous levels. And that in a space no larger than a fingernail. truly global semiconductor foundry. Located in the USA and Germany, Fab 1 in Dresden and the future Fab 2 in Malta, New York. Together, they'll be two of the most advanced chip factories on Earth and a testing ground for the very latest microelectronic innovations from around the globe. The last production step in microprocessor manufacturing is the packaging of the chips. In preparation for this step, tin silver pellets are applied on the wafer. They will link the chip to the frame. Via the finest saw blades, the chips are cut off the wafer. The flip chip method is used to bond the chip to the frame, which is sealed with a cover.
All right, so basically that is just the, in general, this says Global Foundries, but this is how wafers or computer chips are made, right? So there's a very thorough process for it. I can tell you that, you know,
I brought some show and tell here. Looks like we got extra stuff lying on here. Unless you were going to show that too.
Yeah.
Oh,
that was just a YouTube, play the next video. It's
Put it
related to
on
that.
that playlist, but in the nanofabrication program, you know, of course, you have to gown up, just like Pat was mentioning. I didn't see them wear booties. You know, those booties up there.
We wear booties.
Yeah, we
That
wear booties.
was, I think that was Dresden.
Yeah, Dresden wears a clean room safety shoe. It's a white safety shoe,
Oh,
but that's specific for the fab. And then when you change out of the clean room suit, you put on like flip flops to walk around in the office space.
So I
Or
can
your own sneakers, whatever.
bring these to the lab, but yeah, it's quite. I mean, of course, you know, you want to make sure you go to the bathroom first, right, before you gown up, because yeah, you pretty much have to ungown to take a break or anything.
And the one in Dresden, they have a bathroom inside the clean room.
No, Burlington does. They have a couple, but
I think Digital had one too.
Fab 8 we do
In
not.
Massachusetts, at one point.
One room's 300,000 square feet, so.
It's a lot of walking.
In the
to get to
video,
the
that's
bathroom,
the size of 2 soccer pitches, so I think that's 2 football fields.
But anyway, you can. After a while, you don't even think about putting this on anymore.
No.
You have a protocol that you use. And, you can get it in and out of the gown in like what, a minute or two. It doesn't take
Yeah.
long time at all.
It doesn't take long.
Yeah, I wrote a lot on. The good thing is it's a very, I mean, some of the processes are dirty, but it's a very clean environment to be in versus other manufacturing facilities. You know, as a technician, I was a technician for 8 years, so I'll give you a background here in a second, but, you know, like what Jeff was saying, after a week, you're good to go. So, in the first hour, maybe a little uncomfortable, it's like, why, how can I, you know, how am I gonna work in this, but eventually you'll get used to it like with everything else, right? It's like when you go from shorts to jeans when the season's change, right? So,
It's temperature controlled.